Okay, so far we have seen measures of central tendency, and then we saw the measures of variation. In measures of central tendency, you saw mean, median, mode, and in the measures of variation, you saw range, variance, and standard deviation. And now we are going to look at the measures of position. Okay, so measures of position basically talk about the position of particular data values within a data set. So we can divide these data values into sets of data values. For example, we can divide them in quartiles, in deciles, in quantiles, in percentiles. So first of all, we look at quartiles. Quartiles means that we have to divide the total data set into 4 equal parts, whereas the first quarter would be called Q1, the second quarter would be called Q2, and the third quarter would be called Q3, right? And then it ends at the 100th percent. So the first 25% of the data is basically first quarter. The second one is second quarter. The third one is third quarter, and the fourth one is fourth quarter. As you can see that the second quartile falls at 50. And this is the exact center of this data set. And we have earlier told you that median falls at the exact center of the data set. So median is Q2. Remember that. Then median divides the data set into 2 equal parts. So you can see that the 2 equal parts are here, one to the left of the Q2 and one to the right of Q2. And each of these 2 parts also have their center at Q3 and Q1. So you can say that the left half data also has a median, which is Q1, and the right half data also has a median, which is Q3. Okay, so we have 3 medians in this picture. So here is a quiz score of 15 students, and first we are trying to find out the quartiles of the scores. How can we do that? We sort out the data and we find out the middle value. Since there are 15 values, you will have 7 values to the left of the central value and 7 values to the right of the central value. And this central value would be median. And since we are talking about quartiles, at median we have the second quartile. So second quartile divides the data into 2 different parts, where we have the one half and here we have the second half. Now next is to find out the center of these 2 halves. So you can see that there is a center of the left half and the center of the upper half or the right half. So we have Q1 as the median of the left half and Q3 as the median of the right half. So we have 3 quartile values, Q1, Q2, and Q3, and these are very useful values. Why? Because these 3 values, they show us, if we start, if you actually put that data line again here, which starts from 0, and you have your 25%, 50%, 75%, and 100% of the data, you can see that from Q1 to Q3, you have your central 50% of the data. So interquartile range, which is Q3 minus Q1, shows you the central 50% data of the data set. Okay, so if you deduct Q3 from Q1, the answer that you get is 11 in this particular example, and 11 can be interpreted as the central 50% students score. The quiz score in the middle portion of the data set vary by at most 11 points. Okay, so based upon these quartiles, we have an exploratory plot, which is also called a box plot, and this is sometimes extended by the actual characteristics, and it is named as box and whisker plot. And this is based upon 5-number summary. As you know, we can easily find out the minimum and maximum value in the data set, and we just have found Q1, Q2, and Q3. So using these 5 numbers, we can construct a box and whisker plot. So here we have an x-axis on which the values lie, and then we have the minimum value here and the maximum value, and we join them with a line, and then at the value of q1, q2, and q3, we actually create vertical lines, and we join these vertical lines to create a box. So this box shows the central 50% of the data, also the median of the data, and by these whiskers, these lines, you can see that how much the data is, the central 50% data is tilting towards the minimum or the maximum. As you can see, almost similar length of these two whiskers to the left and right of the box. So we can say that this data is normally distributed, which means the data has the center in the exact center. There's not much skewness in the data. But if we have another box plot, for example, let me make another box plot here for you. For example, if we have like this box plot, so you can see that the right whisker is a little greater than the left one. So you can say there's a bit of skewness in the data set. Next, we see that there are other measures of position regarding data values that we can use. Fractals are the numbers that partition or divided an ordered data set. So you can also find out fractals. You can also use percentiles that divide the data set into 100 equal values. And you can also divide them with deciles that actually produce 10 equal parts of the data set. Okay. So then there is an example. A test score at the 80th percentile indicates that the test score is greater than 80% of all other test scores at less than or equal to 20% of the scores. Okay, so you must have been a part of a standardized test. And what I mean by standardized test, that produce the result in the form of percentiles. So if you get 80th percentile in the test, that means that you have performed better than 80% of the people, and you have performed poorer than the 20% of the people.